So in this video हम प्रूव करेंगे कि क्यों Poisson डिस्ट्रीब्यूशन और बाइनोमियल डिस्ट्रीब्यूशन जिसके पैरामीटर्स हैं n, p implies Poisson distribution with the parameter lambda in the limit n tends to infinity, p tends to 0, while n times p is a constant lambda. So हम प्रूव करेंगे कि यदि n इन्फिनिटी को टेंड करे, p 0 को टेंड करे, पर उनका प्रोडक्ट कांस्टेंट हो, तो फिर जो डिस्ट्रीब्यूशन होती है, जो बाइनोमियल डिस्ट्रीब्यूशन होती है, दैट्स एक्चुअली नथिंग बट पॉइसन डिस्ट्रीब्यूशन, जिसका पैरामीटर विल बी दैट प्रोडक्ट n टाइम्स p व्हिच इज नथिंग बट लैम्डा. तो प्रूफ करने से पहले पहले इसको हम देखते हैं कि व्हाट डज इट मीन टू बी मैथ, व्हाट्स द मैथमेटिकल अंडरस्टैंडिंग ऑफ द सी. सो मैथमेटिकल अंडरस्टैंडिंग इसकी ये है कि you are given a random variable x which is sampled from a binomial distribution, या फिर it's a binomial random variable, one and the same thing, जिसके पैरामीटर्स हैं n, p. तो we know कि इसकी probability क्या होगी and we know what its expression is, but what we have to prove कि ये जो probability होगी, so the probability that this random variable x takes some value small x in the limit कि n tends to infinity, p tends to 0, while n times p is lambda, some constant lambda, is actually going to be nothing but e to the power minus lambda times lambda to the power x divided by x vector. So this is what we have to prove, in fact. Okay, so now let's see how we can go about this. But before this, let's see what does it mean to be like, what's the intuition behind this to be true. तो यदि आपको याद हो तो दोनों बाइनोमियल और बर्नूली और पोइसन में क्या डिफरेंसेस हैं और क्या कॉमनैलिटीज है. तो कॉमनैलिटी ऑफ नंबर 1 कि इट इज बोथ ऑफ देम आर मॉडलिंग डिस्क्रीट रैंडम वेरिएबल्स, राइट. और ये भी पोइसन डिस्ट्रीब्यूशन भी डिस्क्रीट रैंडम वेरिएबल्स को मॉडल करने का एक तरीका है. But there is also a difference, and the difference is that that here the collection is finite, or the set from jo binomial distribution, the sample space can be one of the finite values, and we know that what those finite values are. It could be 1 of 0, 1, 2, 3, and on the other hand, the Poisson distribution is for the infinite sized discrete random variables, which could be 0, 1, 2 till infinity, right? और यही चीज हमें दूसरे कॉमनैलिटी को भी थोड़ा इंडिकेट करती है कि, और you can also say कि डिफरेंस को हाईलाइट करती है. So the second commonality between the two is that the binomial distribution is modeling finite or n number of independent identically distributed Bernoulli random variables, और जिसका पैरामीटर है p. Okay, so if you remember कि binomial is actually nothing but modeling the number of successful events, where each of those successful event is nothing but a Bernoulli random variable जिसका पैरामीटर है p, right? And that's why if you remember the expected number of successful events, okay, actually comes out to be nothing but n times p. All right. Poisson distribution also similar. Poisson distribution also see models models independent identically distributed Bernoulli random variables, but with a difference कि वो जो IID Bernoulli random variables होते हैं, they are infinite in number. Okay, so it models infinite IID Bernoulli random variables. All right, but An important point here is that we want very similar to binomial. Okay, and that's actually another similarity. So just like how in the binomial case, the expected number of successful event is given by n times p, which is a constant. We want here as well that similarity to exist. We want the expected number of successful events is also constant. All right, lambda. But what does it mean? So if the expected number of events is constant, lambda, then what do you think it means for, or what does it mean to be the success rate for each of these Bernoulli random variables? So if it is n independent Bernoulli random variables, let's assume the success rate is p, right? So using the binomial, because remember the Poisson distribution is modeling the same thing. It is modeling, the number of successful events in n independent Bernoulli random variables, जिसमें हर किसी का success rate is the same p. But we want n times p to be lambda. But the important point to notice is that this n in the case of Poisson limits to infinity. So what does it mean for the p? So it means if lambda has to be finite where n tends to infinity, p needs to tend to 0. Okay, so this p in fact should tend to 0 for their product to be lambda, right? For the number of successful events, for the expected number of successful events to be a finite. Because if you want the expected number of successful events to be finite and the number of events to be infinite, it cannot happen that the success rate of each of these events is finite. Because if that happens, then the expected number of success, that is n times p, will be nothing but infinity. Why? Because p is finite while n is infinity. So p is finite and n is infinity will be a disaster, because then the product will be infinite, which cannot be. Yes, so and that's why you cannot have expected. So in fact, if you come back to the original problem statement, then all that you required to set up this problem was to say that n is infinity and the expected number of successful event is finite. Because just using these two conditions, does it follow that p should tend to 0? Because this cannot happen that one of these conditions are not true. So it cannot happen that n tends to infinity and p is finite and p is not 0. Or maybe you can say that p tends to 0 and p is finite and n does not tend to infinity. So either of these cases cannot happen. All right, so now you can यहाँ पर आप वीडियो पॉज कर सकते हो और just give it a shot. How can you prove this? All right, so let's come on to the proof. And the proof is actually quite easy. The only hiccup here is you're not able to evaluate the limit, right? So let's just see. Okay, so remember that what we want to prove is that this limit is equal to this particular expression. All right, so let's see that. So let's start from the LHS, right? So what we want to do is that we want to evaluate the limit. Okay, so given x is from binomial whose parameters are n comma p, so what's the probability that x takes some small value x in the limit n tends to infinity, p tends to 0, while np is a constant lambda. So I'll not be writing the thing under the limit again and again, so I'll just be writing this as limit. Okay, but we know that what is the range in which we are calculating the limit. But let's write down what the probability is. So remember कि x binomial random variable है, तो probability का हमें expression आता है which is nothing but n choose x times p to the power x times 1 minus p to the power n minus x, right? Now let's evaluate this. Now remember that a usual way limit calculate करने के लिए ये होता है कि we can just substitute in the values, right? So remember that n tends to infinity, so maybe we can substitute this with infinity. So on substituting the values over here, so you get lambda choose x, so infinite choose x times 0 to the power x times 1 minus 0 to the power infinite minus x. But if you observe, then this is actually not, it does not exist. Why? Because even though lambda choose x exists, or it does not exist, but it definitely evaluates to infinity, 0 to the power x evaluates to what? Now, This is also contentious. Well, no, this is actually not contentious. This is actually nothing. This is exactly zero. The limit that p tends to zero, this is just zero. The problem happens over here because remember that this quantity is not exactly one. This is in limit to one. That means that in reality, this could be either slightly greater than one or it could be slightly less than one. Now imagine if this is slightly greater than one, then a number slightly greater than one to the power infinity will actually give you infinity. But a number slightly less than one to the power infinity is going to give you zero. And that's why the limit does not exist. So this means that, and if you remember, then we have a name given in the literature, and these are called indeterminate forms, right? And the way to evaluate the limits for indeterminate forms is to use, several theorems, right? So one of them is that you can simplify the expression. To give you an example, suppose you have to calculate the limit n tends to infinity of the expression n by n. Now, if you were to just substitute in the value of n with infinity, you would have got infinity by infinity, which does not exist, right? So the way to work around this is that you actually simplify this expression. And if you remember, then, I mean, as you can see, n by n actually evaluates to 1 if n is not 0. And when n is 0, it is not defined. Okay. But remember, we want to just calculate the limit when n tends to infinity. So we are indeed dealing in this domain. और इसीलिए इसकी जो limit होगी, that will just nothing be 1. Okay. So that is why simplifications can help. All right. So maybe what we can do is like simplify this expression, right? And what we'll do कि simplify करते 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 we'll come at a point जहाँ पर we are able to calculate the limit of every sub expression. और तब हम कह देंगे कि हाँ, the limit exists and we can evaluate. But until now we cannot, because there exists a term which is exactly this term which is indeterminate. So we have to simplify it further. So let's see. Achha, before doing any simplification, okay, so let's now do the actual simplifications, and I'll just remove all of this extra stuff which is not required और जो कि सिर्फ clutter कर रहा है यहाँ पर. Okay, so let's see this. Okay, so this is nothing but n factorial by x factorial times n minus x factorial, and this just carries over. All right. अब हम देखते हैं कि अच्छा, now let's note several things. So one thing is that x factorial is a constant because we are evaluating for a given x. So x here is a constant, so that's why this term is a constant, and hence we can just take this thing outside. All right. Now let's observe other things. Achha, another thing to observe is so this guy. So this 1 minus p to the power n minus x can actually be written as 1 minus p to the power n divided by 1 minus p to the power x. All right. And it will become clear that why are we doing this. Okay. Acha, remember that doing this simplification does not really help us with anything. क्यों? क्योंकि ये जो term है ये अभी भी indeterminate है. It is still of the form 1 to the power infinity. Right? So we still have to do some simplifications. So we'll see. Acha, another thing to note is n factorial divided by n minus x factorial. If you observe, then this is nothing but what? This is nothing but n times n minus 1. Acha, by the way, let me change this color. So yes, so as I was saying that this term is nothing but n times n minus 1 times n minus 2 times n minus x plus 1, right? Because जो n factorial होता है, this is how it is defined. यहाँ पर n minus x factorial होगा, n minus x factorial. So you just cancel. Remember that this is the rule of simplification, that we can simplify your expression this way. We just saw that, right? So yes, so we can, that's completely valid. और हमने वो चीज़ कर ली. So now this is what here. Now here we are gonna apply a trick. So the trick is that in the limit n tends to infinity, remember x is finite. So in the limit n tends to infinity, it is actually nothing but the limit n tends to infinity of n to the power of x. Remember, how many terms are we multiplying here? X. And each of these contain a single n. Okay. So it makes sense कि जो इसकी limit होगी when n tends to infinity is actually going to be nothing but this, right? And this actually can prove because this is actually nothing but a polynomial. ये एक polynomial है n में जिसकी degree है x. तो Yeah, okay, so it's just that कि as n tends to infinity, जो dominant term होगा उस polynomial में, that will dominate, right? Or that is why we can just replace it with this particular quantity. And what this means, actually, it may seem as a hack, but आप इसको एक दूसरे तरीके से भी try कर सकते हो, and you will find out कि and maybe I'll give a hint at the end of this video, but yeah, okay, because it's as simple as saying क्योंकि this is nothing but a polynomial in n, और जो degree है it is x, right? So that is why जब आप limit when n tends to infinity will be nothing but the same as limit if you calculate that of n to the power of x. Okay, तो n to the power of x पे जो limit होगी वो इसकी limit के बराबर होगी, because because the dominant term in this expression is n to the power of x. Okay, right? And that is why it's the same as this quantity. That means that we can actually replace this thing with just n to the power of x. Okay, and now if you observe that the other term in the original expression is p to the power x, so n to the power of x or p to the power of x together, what will this give us? So this on multiplying will give us n to the power of x. And remember, in the limit n tends to infinity or p tends to 0, unka product is a constant, right? So this can actually be replaced, again simplified to lambda to the power of x, which is finite. So this means कि ये जो limit है, so this limit together exist, which is nothing but lambda to the power of x. Now let's see about other limits. Now before proceeding to other, observe that one other expression in this limit is 1 minus p to the power of x, right? This particular, let me use this color. So this particular value of x, right? Now remember कि x is finite where p tends to 0. So this thing is actually nothing but of the form 1 tends to the power of x, where x is finite. And if you remember, क्या ये indeterminate है? नहीं. This is not indeterminate. बल्कि इसकी जो limit है, it is actually nothing but just 1 to the power of x, which is 1. Okay, right? Because 1 multiplied by some finite number of times will give you nothing but just 1. That's all. Okay, so this is just 1. So this means कि इसकी भी limit exists, and that is 1. Now let's see if इसकी limit exists. Okay, so to do this is actually commonly discussed thing in in the literature limits, और इसकी जो limit होती है can actually be evaluated this way. So the limit that n tends to infinity and p tends to 0, right, is actually nothing but what can actually be written as e to the power of n log 1 minus p with base e, but I'm removing b. Achha, now you can actually apply Taylor series here, right? So if I apply the Taylor series, then this will give me what? Minus p squared by 2 minus p cubed by 3, so on and so forth, which is nothing but np minus np squared by 2 minus np cubed by 3, so on and so forth. Okay, अब हम क्या करेंगे यहाँ पे? अब यहाँ पर आप लिमिट लगाओ, n tends to infinity, p tends to 0. So remember, n times p is a constant lambda. The other things as well, lambda appears, right? So this is nothing but again the limit e minus lambda p by 2 minus lambda p square by 3, so on and so forth. But remember, because p tends to 0, so all of these terms vanish to 0, and the only thing that remains is e minus lambda. So ye is nothing but e minus lambda, e to the power minus lambda. So finally, now we can combine all of these things together. So the limit of this particular expression, the limit of this particular expression exists, and that is nothing but lambda to the power of x. The limit of this particular expression, as we just saw, is nothing but e to the power minus lambda, and of this exists, and it's nothing but 1. So combining all of these together, we get, remember, there's also 1 upon x factorial outside. So 1 upon x factorial and e minus lambda divided by, or sorry, e minus lambda times lambda to the power x, which is nothing but, yes, e minus lambda times lambda to the power x by x factorial. And if you recall, then this is nothing but, Poisson distribution with parameter lambda, and hence proof.